Hi, good evening everyone. I am Lamya, Assistant Professor RTC, Coimbatore. So, today we are going to start with an interesting topic. Nowadays, transistors, so hope we are using all the gadget at home, right? So, these transistors are the basic building blocks of all the electronic gadget. So, very simple, when we take the mobile phone it is made up of many type of transistors, many micro transistors inside. So, one of the important transistor which we are seeing here is the Mosfet. Okay? So, Mosfet means it's from the name itself we can see it is metal oxide semiconductor field effect transistor. So, in this video we are going to learn about the basic current and how the Mosfet is made and also the working condition of the Mosfet. So, these are the things which we are going to see in this video. So, now let us see what is a Mosfet. So, Mosfet is metal oxide field effect transistor. Before knowing that, we should know how the normal current works. So, always the charges, the flow of charges, we call it as the current. So, the electrons, when there is a high potential between the two terminals of the battery, the electron starts, and when the terminals are connected by a conductor, the electron starts moving from the negative terminal to the positive terminal. So, when the electrons start moving from the negative terminal to the positive terminal, opposing force flows. That force we call it as the current. But conventionally we call current flows from the positive direction to the negative direction. So, now let us come to this conductor. So, which conductor is used here? So, here a normal conductor is used here and we are having a switch over here. So, this can be accomplished for a normal circuit. But in small electronic device, we need to control the current in a specific manner. For that, we cannot use a normal conductor. For that, we need to use a special conductor. So, those things we call it as a semiconductor. So, semiconductor, the conductivity lies between a conductor and a non-conductor, or we call it as an insulator. The conductivity can be adding some impurities in it. So, here the conductivity varies between, so silicon, we are taking silicon, germanium, these things as a semiconductor. The conductivity lies between a non-conductor and a conductor, that is a non-metal and a metal. So, how this silicon conducts? It is when, so already we would have learned what is meant by semiconductor and what is meant by doping. So, I am just going a short overview of what is doping. So, what happens? So, silicon, phosphorus and boron. For example, in silicon if phosphorus, so phosphorus in its, it is a pentavalent impurity, okay. So, when a pentavalent impurity is added, it is converted to a N-type semiconductor, and when a trivalent impurity is added, it is made into a P-type semiconductor. So, what is trivalent? The valency is 3, it will be having 3 valence electron, it is not valency, sorry, 3 valence electron, and here 5 valence electron. So, what happens in N-type? It is having 5 valence electron, already silicon is having 4 valence electron. So, 4 will be forming covalent bond with them, and the extra 1 electron will form the, it is responsible for as a conducting. So, these are the majority charge carriers. So, here in N-type, the electrons are the majority charge carriers, and in P-type what happens? What we call it as a P-type? When there is a insufficient of 1 electron, for example, a 4 electron should be there. Instead of that, in the valence electron, when we dop, that is a trivalent impurity, there will be only 3 electrons. So, there will be a deficiency of 1 electron. Okay? So, that deficiency we call it as a hole. So, that hole will be the majority charge carrier. Since it is a hole, that is the missing of electron, we call it as a P-type, that is the holes, the majority charge carriers are the holes. So, that is what is a P-type semiconductor. Now let us see what happens when a p-type and n-type semiconductor joins together. So when we join a p-type and a n-type, so it is an n-type and it is a p-type. So here electrons are the majority charge carriers and here holes are the majority charge carriers. So what happens here, as the opposite charges attracts, here a layer is formed. Some of the electrons will try to move here and some of the holes will try to move this area. So a layer will be formed. This layer we call it as a depletion layer. So in this part, when we, for now this is n type and this is p type. Okay. Now when we apply negative charges here, already it is having more electron, right? So it is already having more electron and those electrons, so when negative charge is applied here, the electrons will be pushed. It tends to push to the other side, and here this positive charges, as the positive and positive repels, this positive charges tend to push the hole in this side. As a result, this depletion region, what happens? It will reduce. So the depletion region reduced and it will go to a certain point. So after that point, this material starts conducting the electricity. Okay. So the voltage at which this junction starts conducting is called the threshold voltage. Okay. Now when we reverse, see, when we reverse this positive, when we give positive charge here, what happens? The same opposite thing happens. The electrons are attracted by the positive charge and the holes are attracted by the negative charge. As a result, the depletion region increases. So to the p-type, n-type side, when we give a negative charge, if n is given a negative charge, that we call it as a forward bias, and when p is given a positive charge, when n is given a positive charge, that we call it as a reverse bias. Now let us come to the types of Mosfet. So there are two types of Mosfet, that is two modes of Mosfet. One is enhancement mode and another one is depletion mode. Okay. In enhancement mode, further it is divided into two types, that is one is p-type Mosfet and n-type. In the same way, in depletion mode it is divided into two types, one is p-type and another one is n-type. Okay. So these are the types of Mosfet. In this, so for example, when we see here, so here we are going to see about the n-type enhancement Mosfet. So we have a substrate which is a p-type material and there are two portions, that is the source and the drain, which is a n-type semiconductor. So and the substrate it will be connected. So this will be the source and that will be the drain. So this terminal, so in between the terminal we have the gate. So as the name suggests, it acts like a gate between the source and the drain. So in see, both are the n-type material. So we can't take this as a drain and that as a source. In order to differentiate that, the source is connected to the substrate body and now this is the gate. So what happens? So if we want to flow current from the source to gate, there is no connection, there is no potential difference, hence no flow of current will be there. So when we connect it here, what happens? There is, see for example, when positive is connected to the negative terminal, what happens? It is in what bias? It is in reverse bias. So this depletion layer keep on increasing, it will be keep on increasing and no current will flow over it. See, it is keep on increasing. So, in order to achieve the flow of current, what we need to do is, we need to form a channel between the source and the drain. Okay. So, how the channel can be formed? There comes the purpose of the gate. Okay. So, in order to give a channel between the source and the drain, a gate terminal is connected with the power supply. So, it is a voltage controlled Mosfet. So, a gate is given a positive charge. So actually it is, we have a, why we have called it as metal oxide semiconductor material, we have a silicon dioxide here. So it acts like a capacitor. So how a capacitor acts? It is in between two plates there will be a dielectric inside which stores the charges. In the same way this gate terminal acts like a capacitor, and its positive charge, the positive charge will keep on accumulating, and what happens from the P substrate, if it is accumulated by positive charge, what it will do? It will automatically tend to attract the electrons over here. As the electrons in the P substrate are the minority charge carriers, at initially only a very little amount of electrons will come, and when we apply more voltage, the P, that is the holes, it will repel to the other side and it will move to the other side. As a result, what is formed? A channel, a N gate is formed here. Now you can see, now when we connect the positive terminal here and the negative terminal here, automatically there will be a flow of current. So this is how the gate, as the name denotes, this gate acts as a gate between the source and the drain. But this gate is controlled by a voltage that we call it as VGS. Okay, so that is what is the purpose of gate. Now you can see the flow of charges. So as the flow of charges is accompanied here, and one more thing happens, as more charge and when we apply more voltage here, what happens? Again it is positive and this part is negative. This layer tend to deplete, you can see, right? This layer tend to deplete, yes, and the channel is becoming narrow in this side, okay, in the drain portion. So it will not completely get closed, but it will be having a small channel. So this region we call it as, here it is getting stabilized, okay. So after that it will not, the flow of current will not increase. So if we want to increase the flow of current, what would be the possible way? You can just guess what would be the possible way. Of course we need to increase the space. In order to increase the gate, what we need to do? We need to apply more current here. Yes? So are you clear about how the Mosfet works? Hope you are clear here. So we will see what are the different regions in which the Mosfet works, and also what are the types of Mosfet in the next class. Thank you.